All right, good morning, guys. Let's go ahead and get started. Today we're going to be doing 5.4 quadrilateral practice. Our learning target is I can prove properties of parallelograms. I can solve problems using properties of parallelograms. So let's go ahead and jump right in. First off, which property is true for all parallelograms? We have A, diagonals are perpendicular. B, all angles are right angles. C, diagonals bisect each other. And D, base angles are congruent. And again, we're focusing on all parallelograms. Not just parallelograms, but it also holds true for rectangles, rhombi, and squares too. So, out of all four options, the only one that's true for all parallelograms is C, diagonals bisect each other. The other ones are true for different types of shapes. So for letter A, diagonals are perpendicular. That's true for rhombuses, squares, and kites. It's not true for rectangles, though, and a rectangle is a a rectangle is a parallelogram, so that's not true for all parallelograms. Letter B, all angles are right angles. That's true for only rectangles and squares. It's not necessarily true for rhombi, so therefore it's not true for all parallelograms. Then letter D, base angles are congruent. That's true for just isosceles trapezoids. It's not true for any parallelogram. All right, let's go ahead and move on to our next question. These next couple questions are going to be a little bit more difficult, and you guys will see them in the future as well. So, determine the type of quadrilateral. We're given points A, B, C, and D. First thing that we need to do is we need to graph these points on our graph. And right away, we can kind of tell what type of quadrilateral it is. Looking at it, it looks like it's going to be a trapezoid, maybe an isosceles trapezoid. But when we're going through these types of problems, we need a couple things to make sure that we have in our notes, because you will be asked these types of questions on the test. And what I'm going to be looking for is slope. So again, for slope, we can use y2 minus y1 over x2 minus x1. You can also use rise over run if you'd like. And then I'll also be looking for distance. So the distance between points. And for distance, you can either count if it falls flat on the grid, or you can use the distance formula. x2 minus x1 squared plus y2 minus y1 squared. That will also get you the distance between 2 points in a graph. So, starting with these two formulas, we should be able to find the distance of each side and the slope of each side to determine which type of quadrilateral this is. So, starting off with segment AB. AB falls flat on the line, so I should just be able to count AB and find out its distance. So for AB, we have 1, 2, 3, 4, 5, 6. So AB is equal to 6. Further, its slope is 0. And the way that I got the slope is rise over run. I rise 0 places, I run 6. Well, 0 divided by 6 is just 0. So that's where that slope came from. Next, we do the same thing, except this time I'm going to go to the opposite side, CD. And if this is a trapezoid, CD should be parallel to AB, but it probably won't be the same size. So let's go ahead and count, because it does fall flat on our grid. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So CD is equal to 10. Also, its slope is 0, because again, my rise is 0, my run is 10, 0 over 10 is just 0. So therefore, these lines are parallel. Now, the definition of a trapezoid is that we have one pair of parallel sides, which is the case right here. That's exactly what we have currently. So now we're going to check the other sides. So next, let's go ahead and check the distance of BC. To check the distance of BC, we'll use our distance formula. So the distance formula for BC, we have the square root of x2 minus x1 squared plus y2 minus y1 squared. Now give us -4, double negatives turn to a plus, so -4 plus 6 is 2, 2 squared is 4. 10 plus 1 is 11, 11 squared is 121. 4 plus 121 gives us radical 125, which we can reduce if we want to 5 radical 5. You don't need to reduce it, but you can. So therefore, this distance is 5 radical 5. And again, I want to find the slope just in case. Don't want to make a silly mistake and actually have a parallelogram here. So finding the slope, I use y2 minus y1 over x2 minus x1, which will give me 10 minus negative 1, which will give me 11, over negative 4 minus negative 6, which will give me positive 2. So our slope is 11 over 2. Next, we move on to segment AD. If this is a trapezoid, it won't have the same slope as BC, but if it's isosceles trapezoid, it will be congruent to BC. So let's go ahead and check AD's distance. Again, we're going to use our distance formula, x2 minus x1 squared plus y2 minus y1 squared. That'll give me 2 minus 4, which is negative 2, squared. Negative 2 squared is positive 4. I also have 10 minus negative 1 squared. 10 minus negative 1 is the same as 10 plus 1, which will give us 11, 11 squared being 121. 4 plus 121 will give us 125. The radical 125 reduced is 5 radical 5. So these two segments are congruent. They're the same. And further, if I find the slope, I find out that the slope is negative 11 over 2. So their slopes are opposites. So they are not parallel sides. BC is not parallel to AD. Therefore, since we have one pair of parallel sides, that means it's a trapezoid. Since the legs are congruent, it means it's isosceles. So therefore, this is an isosceles trapezoid. Again, make sure that you know how to do this type of question. You will see it in the future. Next up, we have another question that's very similar to this. So again, we're going to determine the type of quadrilateral, but this time, A is at negative 8, 5, B is at negative 2, negative 5, C is at 8, 1, and D is at 2, 11. So looking at this shape, it looks like it could be a parallelogram. It looks like it could maybe be a rectangle. And looking at it, it could also be a rhombi. So if it's all three of those, then it's probably going to be a square. But we need to prove that it's a square. We need to have our evidence behind it. So the first thing that we're going to do is let's go ahead and focus in on finding the distance and the slope of AD. Because the distance will tell me if it's a rhombus. The slope will tell me if we have right angles. And further, the slope will also tell me if it's a parallelogram. So using all this information, slope and distance, we can find out what we need. So to get started, we're going to focus in on AD. We're going to find the distance of AD using our distance formula, x2 minus x1 squared plus y2 minus y1 squared. That will give me negative 8 minus 2 squared. Well, negative 8 minus 2 is negative 10. Negative 10 squared is 100. And I also have 5 minus 11 squared. Well, 5 minus 11 is negative 6. Negative 6 squared is 36. 100 plus 36 will give me the square root of 136. As for our slope, we'll use y2 minus y1 over x2 minus x1. 11 minus 5 is 6. 2 minus negative 8 is positive 10. 6 over 10 can be reduced down to 3/5. Next, we move on to AB, doing the same exact thing, distance formula. So for AB, we have negative 8 plus negative 2, negative 8 minus negative 2 squared, plus 5 minus negative 5 squared. Double negatives turn to a positive. Negative 8 plus 2 is negative 6. Negative 6 squared will be 36. 5 minus negative 5, that turns to a plus. So 5 plus 5 is 10. 10 squared is 100. 36 plus 100 will give us 136. So the distance is radical 136 once again. So these two sides are congruent. Well, currently, if we have two consecutive sides that are congruent, that means that could also be a kite. We don't know. We're not sure yet. We need to find out a little bit more information. So next up, we're going to go ahead and find the slope of AB. Again, we'll use our slope formula. So for our slope formula, we'll have negative 5 minus 5 over negative 2 minus 8. Negative 5 minus 5 will give us negative 10. Negative 2 plus 8, because again, double negatives, will turn to positive 6. Negative 10 over 6 will give us negative 5/3. Well, looking at these two slopes, the blue and the red, they are opposites and they are reciprocals, meaning we flip the fraction and we change the sign. What that means is that they are perpendicular. And if two segments are perpendicular, they intersect at 90 degrees. So therefore, angle DAB is a right angle. Next up, let's go ahead and check BC next. So for BC, we find the distance using our distance formula. -2 minus 8 squared plus -5 minus 1 squared. -2 minus 8 will give me -10. -5 minus 1 will give me -6. -10 squared is 100. -6 squared is 36. 100 plus 36 is radical 136. So now all three sides are congruent so far. Let's go ahead and check and see if angle B is a right angle by finding the slope. Again, we find the slope by using y2 minus y1 over x2 minus x1. So we have -5 minus 1 over -2 minus 8. -2 minus 8 will give us -10. -5 minus 1 will give us -6. So we have -6 over -10. Negative divided by a negative is positive, so the slope is 3/5, positive 3/5. What that means is that the blue line and the purple line are parallel. And the purple line and the red line are perpendicular. So if the blue and the purple, a pair of opposite sides, is both congruent and parallel, then this is a parallelogram. So we've now proven that this is a parallelogram just by finding the slope and the distance of one pair of opposite sides. Let's go ahead and find DC so we can make sure that we have an accurate guess for this shape. So for DC, we use distance formula once again. So we have 8 minus 2 squared plus 1 minus 11 squared. 8 minus 2 will give us 6. 1 minus 11 will give us -10. 6 squared is 36, -10 squared is 100. 100 plus 36 will give us radical 136 once again. So now all four sides are congruent, which means that we have a rhombus. But we need to make sure that we're more specific. So let's go ahead and find our slope so we have all of our evidence. But right now, I can also say that this is a rectangle because it is a parallelogram that has at least one right angle. If it's a parallelogram with one right angle, that means that it is a rectangle. But just to make sure, let's go ahead and find this last slope so we can see if these angles are right angles. So for our slope, we use 11 minus 1 over 2 minus 8. 11 minus 1 is 10. 2 minus 8 is -6. That reduces down to -5/3. So red and green are parallel. Blue and purple are parallel. Therefore, this is a parallelogram. Further, we have opposite reciprocal slopes. So therefore, we have four right angles, making it a rectangle and a rhombus. However, if a quadrilateral is a rectangle and a rhombus, then we classify it further as a square, because a square is both a rectangle and a rhombus. All right. So those are our two difficult questions that you guys will see in the future, so make sure that you guys do know how to do those. Next up, we're going to go ahead and work through some property problems. So our first property problem, if ABCD is a parallelogram, find the value of x. So for the properties of parallelograms that we would use here, we'd want to use that opposite sides are congruent. So 7x plus 2 equals 9x minus 28. From here, I can subtract 7x and add 28 to both sides, giving us 30 equals 2x. Then dividing both sides by 2, we get x equals 15. Next up, if QRST is a parallelogram, find the value of x. So again, we know it's a parallelogram, so I can only use those properties. So therefore, one of the properties that we can use, since we're given opposite sides, is that opposite sides are congruent. Therefore, I can say 4x plus 29 equals 10x minus 19. Solving for x here, I'll subtract 4x from both sides and add 19 to both sides, giving me 48 equals 6x. When I divide both sides by 6, we get x equals positive 8. Next up, if JKLM is a parallelogram, Find the value of x. So again, we're given a parallelogram. Which property from a parallelogram can we use? Well, we have opposite angles. And in a parallelogram, we know opposite angles are congruent. So therefore, I can say 5x plus 16 equals 8x minus 20. If I subtract the 5x from both sides and add 20 to both sides, I get 3x equals 36. And when I divide both sides by 3, we get x equals positive 12. All right, our last easy one is if DEFG is a parallelogram, find the value of x. So the property that we can use here, since we have two of these angles, and they're consecutive angles, one comes right after the other as I move around, they are supplementary. So therefore, I can say that these angles will add to be 180 degrees. 3x minus 20 plus 4x plus 11 equals 180. Combining like terms will give us 7x minus 9 equals 180. And from there, I can add 9 to both sides, give me 7x equals 189. The last thing that we can do to get x by itself is to divide both sides by 7, giving us x equals 27. All right, now we're going to move towards a little bit more difficult types of questions dealing with different types of quadrilaterals. The first one that we'll see is a kite. Find the measure of angle ABC from kite ABCD. So the first thing that we can do here is, since we know that this is a kite, I know that my diagonals will be perpendicular. So therefore, all four of these angles are 90 degrees. Now, if this angle here, CED, is 90 degrees, but it's also 5x plus 10, I can say 5x plus 10 equals 90. From there, I can subtract 10 from both sides, giving me 5x equals 80. And then when I divide both sides by 5, we're left with x equals 16. X equals 16. Now that I have x, I can go ahead and find this missing angle over here, angle BCE. I plug 16 in for x. We have the measure of angle BCE is equal to 3 times 16 minus 14. 3 times 16 is 48, minus 14 is 34 degrees. Now, we just need to find these two missing angles up top here. So to find these two missing angles, I'm going to go ahead and use these right triangles. So I'm going to start with triangle BEC. I know for triangle BEC, we have 34 degrees and we have 90. So therefore, angle CBE is equal to 90 minus 34, which gives me 56. The reason that that works is because angle CBE is equal to 180 minus 90 degrees. 180 is the total amount. 90 degrees is my right angle, and then I have 34 degrees as well. Well, 180 minus 90 will just give me 90. So that's where this 90 came from. So I'm just doing a little bit of a shortcut there. From here, we go ahead and we do the same thing for angle ABE. So we have 90 minus 14, which will give us 76 degrees. Finally, we add these angles together to give us our grand total. So angle ABC is equal to 76 plus 56, which is 132 degrees. All right. Easy is a rhombus with perimeter of 72 units, and AEP is equal to 30 degrees. Find AY. So to get started on this problem, we know that we have a rhombus, and we know that all sides in a rhombus are congruent. So if the perimeter is 72, I can break up that 72 units into 4 congruent parts. So therefore, 72 divided by 4 congruent sides will give me each side as 18 units. I also know that angle AEP is 30 degrees. And since this is a rhombus, the diagonals are perpendicular. So therefore, we're going to have 90-degree angles inside of our triangle, which makes this triangle a 30, 60, 90 special right triangle. So I'm going to go ahead and draw another special right triangle up here. Again, this is a 30, 60, 90 special right triangle, and this is the ratios that we can go with. So I notice that the hypotenuse is 2x, the side opposite 90. The side opposite 30 is just x, what we're trying to find. And the side opposite 60 is x radical 3. So if I look at my triangle that we have over here in our rhombus, I see that the side opposite 90 is 18. So therefore I can say 2x equals 18. From there, I can solve for x. Dividing both sides by 2, x is equal to 9. Now, since this is a rhombus, diagonals also bisect each other, because a rhombus is a parallelogram, and one of the properties of a parallelogram is diagonals bisect each other. So therefore, py will also be 9 units. Therefore, if I want to find ay, I'm going to use 9 plus 9, which will give me a total of 18 units. Make sure that you guys know this one. You will see it down the road. Next up, help is an isosceles trapezoid with bases EL and HP. Find EL. So since this is an isosceles trapezoid, we know that we have base angles that will be congruent, so upper base angles and lower base angles. And we also have same side interior angles that are supplementary. So therefore I can say angle H plus angle E is equal to 180 degrees. Now I don't know what angle E is, but I do know angle L and angle E are the same, so I can go ahead and substitute in 3x plus 10 for angle E. So I now have 7x plus 3x plus 10 equals 180 degrees. From here I can combine like terms and subtract 10 from both sides, giving me 10x equals 170. And from here, I can go ahead and divide both sides by 10, give me x equals 17. Lastly, if I want to solve for EL, I'm going to go ahead and take 17 for x. I'm going to plug it into the variable x here. So I have 5 times 17 plus 27. That'll give me 85 plus 27, which is a grand total of 112 units. All right, our final question of the day. If ABCD is a square, find the value of x. So since this is a square, we know that the diagonals are congruent and that they also bisect each other. Diagonals are congruent is a property of a rectangle, which a square is. Diagonals bisect each other is a property of a parallelogram, which a square is. So therefore, I can go ahead and say x plus 5 is the same as 2x plus 15. So x plus 5 equals 2x plus 15. From there, I can go ahead and solve for x by subtracting an x from both sides and subtracting 15 from both sides, which will give me x equals negative 10. With that, we are done with today's notes. If you guys have any questions or need anything, please let me know. But thank you guys so much for watching. I hope that you have a